Today we're going to be talking about building desktop apps with JavaScript. So who is this guy? My name is JD Hillen. I'm a software engineer too at Garmin in Kansas City. Is anybody familiar with Garmin? Does anybody have any Garmin products on them? No. Okay. I got to justify my being here to my bosses, so I always got to shout that out. Anyway, I'm a software engineer at Garmin, so if you have purchased one of their products and registered it online at any point in time, then you have worked with the software that I work with. I have three philosophies in life, and they are code, coffee, and metal. I am a huge code nerd. I drink coffee all day long, and then I am a huge metal nerd. I love music. I went to 3 concerts in the last week. It's probably why my throat is all screwed up right now anyway. But I love being in a live music setting. And lastly, these are my links down here. It's just links.jdhillen.com. You can find the slides to this. You can find all my social media there. I pretty much cross-post everything. Please follow me. I enjoy meeting people. I enjoy carrying on the conversation on Twitter or X or Mastodon or Blue Sky or whatever the hell they're using these days. Please follow me on there. I'll follow you back, and we can keep this conversation going. So, you want to develop an app. Anybody get this reference? Nobody? Nobody? Rick and Morty? Come on. All right, you son of a bitch, I'm in. So, the problem is we want to build an application using web technologies that I already know. So this leads us to, like you said, Electron.js. Electron.js is a cross-platform desktop app, or allows you to build cross-platform desktop apps with HTML, CSS, and JavaScript. You can check out their website. It's just electronjs.org. So what is Electron? Electron is an open source framework for, like I said, building cross-platform desktop applications using web technologies. It allows developers to leverage their web development skills and tools to create desktop applications that run on Windows, Mac OS, and Linux. Electron.js combines the Chromium rendering engine for displaying web content and the Node.js runtime for accessing operating system resources and native APIs. Supports packaging and distribution as applications are standalone executables or installable packages from various platforms. And Electron.js has a very large and active community, providing a rich ecosystem for plugins, libraries, and developer tools to enhance productivity and address various development needs. So a little bit of history. Electron.js was originally known as Atom Shell around 2013 and was developed and introduced by GitHub. The GitHub team created Electron.js to build the Atom text editor, which I'll get to in a second. Aiming to provide a framework that enables web technologies to be used for building cross-platform applications. It then recognized the potential of this framework beyond Atom, and GitHub open sourced it in 2014, renaming it Electron.js. And since then, Electron.js has gained significant popularity and adoption into the development community, leading to its continuous growth and evolution with contributors and developers worldwide. So this is Atom Editor. Did anybody use Atom Editor? It was pretty cool. It was really cool. It's a little slow. It had its things, but it was a really big step forward in terms of an IDE, an open source IDE, a cross-platform IDE. And unfortunately, Atom Editor was sunset in late 2022. So with Electron, there are two processes, excuse me. There's the main process, which acts as the orchestrator, and we'll talk about that next. And then the second is the renderer process. So this handles all the user interfaces. So like it says here, this separation allows for efficient resource management, security isolation, and enhanced responsiveness in Electron.js apps. So let's talk about this main process. This main process is the entry point of all of our Electron.js applications. It runs in a node environment and represents the application's backend. It controls the lifecycle of the application, manages system-level events, and provides access to native operating system functionalities through node APIs. The main process typically handles tasks like creating windows, managing application menus, handling system tray icons, coordinating communication between the renderer process and the main process. That all happens here. And it also has full access to the Electron.js APIs and node modules, enabling interactions with the underlying operating system. So you can use those NPM packages if you want to, which is really great. Real quick, let's talk about Node. How many people have never touched Node in their life? Cool. So everybody's kind of touched. I won't talk too much about Node, but basically the reason that we're using Node is because it bridges the gap between the web technologies and the native capabilities. This means developers can run Node modules, APIs, libraries to interact with the file system, network, processes, and other system-level functionalities. So that's the reason why we're using Node. Okay, so the second half of this is our renderer process. So the renderer processes are responsible for rendering and displaying the application's user interface. Each renderer process corresponds to a web page or a window in the application. Renderer processes run in a Chromium browser context and utilize web technologies such as HTML, CSS, and JavaScript, like we already talked about. They handle the UI logic, the user interactions, and render of the application's web content. The renderer process are isolated from each other, meaning that they operate in separate contexts and cannot directly access each other's memory or values. There is a way to get around that, though, and it's called the IPC, which is the inter-process communication. And that is an API built in to Electron.js that allows that communication between the main process and the renderer process. So, like I said, we're using Chromium under the hood. So Chromium is an open source web browser project initiated and maintained by Google with a Chrome name. Of course, it's Google. It serves as the base for several popular web browsers. And Chromium provides a rendering engine that interprets and displays all the web content and all your other web technologies. It offers extensive customization and flexibility, allowing browser vendors to modify and enhance Chromium to suit their specific needs and branding. And when I say that Chromium is the basis of a lot of these browsers, well, these are all the browsers that use Chromium as their base. Even Microsoft Edge, Opera, Brave. Does anybody use Polypane at all? If I had to give you one piece of advice, check out Polypane. It is a paid service. I think it's like 10 or 15 bucks a month. But if you do a lot of mobile development, especially a lot of responsive design and anything with metadata or SEO, they have a lot of really cool features in Polypane that allow you to develop your application in a much easier way, having multiple windows open at the same time, scaling, things like that. It's a really great product. I highly recommend you check it out. So let's talk about the pros of Electron.js for a second. Obviously, cross-platform development, so it allows you to build those cross-platform applications. Utilizing your web development skills, so you don't need to learn new languages or new frameworks. You can just use what you're normally used to. It does provide a native-like experience with access to the system-level APIs and the native window controls and native functionalities. This allows developers to create desktop applications that feel and behave like native applications on each platform. Again, there's an active community and ecosystem. There's a wide range of plugins and libraries and developer tools that are available. But the most important pro, in my opinion, is the code reusability. So with Electron.js, the reusability of code is maximized. Developers can reuse their existing web code base, components, and libraries when building these applications. This reduces duplication of effort, simplifies maintenance, and promotes consistent functionality across different platforms. So basically, anything that you put on the web, you can port over to desktop, and it would be the exact same experience. Not having to have multiple repos and monolith repos and all those things, trying to keep separate code bases together. Now, let's talk about the cons. So the number one kind of con in this whole Electron.js argument, I guess, is the performance overhead. So the applications do have a larger memory footprint and can consume more system resources compared to native applications. The additional layers and dependencies involving in running web technologies within a desktop environment can result in performance overhead and slower execution. So they are a little bloated compared to native apps, but with Electron.js, it combines Chromium in every single instance of your application that you're installing. So if you have multiple applications that are all using Electron, you have multiple different installations of Chromium on your machine just to render that application. Second thing, there's a learning curve, obviously, with anything. There are Electron-specific concepts and architecture and best practices. So there is a little bit of a start time to it. The distribution size, we already kind of talked about that. It does have a larger distribution size because you're packaging Chromium in every application. There is a little bit of a limited UI customization. Obviously, services like Ionic that do web components that look native on Android versus iOS. It's the same kind of thing. It just hasn't been fully fleshed out for desktop environments. So that's why you see a lot of these desktop environments that they look on Windows more like a Mac app because they're using those different web components. But there is places that you can customize the UI, and we'll talk about that here in a minute. And then debugging complexity. So debugging can be a little more complex compared to traditional web development. But one of the things that I do like is because you have Chromium built in to your Electron app, you automatically have access to the Chrome Dev Tools. So you can just right-click on your application, pull up Inspect Element, and you have the entire suite of Chrome Dev Tools built right in, which is really, really handy because I dev in Chrome and I'm really used to it. So, I don't use apps that are bloated and based off of Google technology. Do you though? Do you really? What about apps like Dropbox, Postman, Trello, 1Password? Anybody use these? Couple? Yeah. What about Figma or Notion or Hyper, which is a terminal replacement? The most popular communication apps on the web: Slack, Discord, Twitch, WhatsApp. And yes, even your precious VS Code is an Electron app. So all of these apps are all Electron apps, and I guarantee there are people in this audience that have those apps built into their machines right now. Okay, the other thing about that argument about the applications being bloated, if you have anything installed that was made by Adobe or Microsoft, you don't get to bitch about file size, okay? That they're bloated. That's just the way they are. So LOL on you. Okay, let's talk requirements. So let's say we want to get an Electron app going. We do have a couple parameters that we need to work on. So it does, Electron is supported for Node 18.15 and higher. For Mac OS, it's High Sierra and up. For Windows, Windows 10 and up. And then Linux, I'm not really familiar with Linux. I tried to build a file server with Linux one time like 15 years ago and I failed miserably. So I was like, I just abandoned that entire industry. I was like, nope, Linux is not for me. So, but those are the Electron builds for Linux. So with Electron, there are a couple things that you need to do. So I said that this was originally titled as just a Vue talk, but really it's not just about Vue. It's about just any JavaScript that you want to do. But this template that I'm starting from is a Vue template that I keep up to date. So when I start new Vue projects, this is what I use. The URL is down on the bottom. If you want to fork it or use it, go ahead. So the first thing that we need to do is install our Electron. Obviously, npm install Electron, save dev. But there are two things that actually need to be added to your application in the root, and we're going to talk about those now. So the first one is this preload.js. So preload.js is basically just telling it that, oh, this is a Chrome app, it's using Node, it's using Electron, this is what we're using. So we have to add this, and this is just boilerplate text that you can find on their website. It's in their install script. This is nothing new and nothing custom written by me. So the second thing that you have to have is a main.js file. So this main.js file is going to serve up the actual files and application to Electron. So you can see down right in the middle where it says win.loadFile dist index HTML. That's the path of your application that you need to pass it, and then it'll load properly. The two functions down the bottom are just create window, so you're actually creating a new window, and then close window, so that quits the app. You can update that so the app actually runs constantly in the background if you want to by closing the window. But again, this is just boilerplate that is provided directly by Electron. So the next thing I'm going to talk about is a relatively new project from Electron called Electron Forge. So Electron Forge quickly scaffolds an Electron project with a full build pipeline already built in. It basically takes those build steps and turns it into a workflow that's already predetermined. It uses GitHub. It allows you to port the apps out to the different various app stores that are out for Windows, Mac, and Linux. It provides the toolkit for Electron.js applications. It simplifies the process of setting up and initializing new Electron projects with pre-configured boilerplates. And one of the cool things is that you can actually set it. Hold on a second. I talk about that in a second. More on that in a minute. But Electron Forge provides commands for building, packaging, and distributing the Electron.js application. So they've kind of removed that from the main Electron.js, and they've built it into Electron Forge. So Electron Forge, same kind of thing, just npm install it, and then we run this command npx Electron Forge import. And what that does is not only it installs, you can see under the dev dependencies down the bottom, the CLI, the maker dev, the maker RPM, maker squirrel, maker zip, those were all imported by that last Electron Forge import statement. But what it also has done is added a couple scripts down at the bottom. So you have Electron start, which is the actual command to start your application. And then you have the Electron Forge start, Electron Forge package, and Electron Forge make. And we'll talk about those here in a second. But for a desktop app, this is pretty much all the things you need in terms of npm packages in order to get set up. And even some of these aren't even necessary, like Axios, Sass. Sass is maybe important. I like working in Sass. But anyway, when you start a new project, you can actually utilize the CLI to start your new project. So npm init, the Electron app at latest, so you're going to get the latest and greatest stuff. You give it a name, so my new app, and then the templates down the bottom. You can actually pass what kind of template that you want to use. You can use Vite, you can use, what's the other one? What did Vite replace? Webpack, thank you. Brain fart there. I hated Webpack for the longest time. It was so bloated and so slow. And then Vite came along and I completely forgot Webpack's name. So, and then also we add this this other file in our index directory, forge config. And what this forge config does, this is automatically installed, but it basically allows you to set what operating system you want to export to. So you can see in the middle line there, we've got this Darwin, which is Mac and Linux. And so when I run that maker zip command, it's going to go ahead and automatically package everything for Mac and everything for Linux. And it's just a simple string that all you have to do is pass that in and it'll automatically go. So now that we have our app, we run npm make. And it spits out all this stuff. So you can see there is the app, the electron-view, and I blew up the file size on there because this is a boilerplate project and it spits out at 234 meg. I don't know about you, but that's pretty big for an application, especially one that is pretty simple to do. I'm gonna drag this over if I can see it here. Yeah, so this is all the app is. It's literally just a web page. You know, nothing fancy, couple links, couple components, but this is just the basic boilerplate Vue application when you create one. And it still comes out at 234 megs, which I think is a little much. I lost my mouse, hold on. Come on. Okay, here we go. So next thing, customizing your app. You know, I keep saying that there are limitations and you can work with your app. So what are some of the things that you can automatically work with to make your app awesome? First up, app icons. You can change any of the app icons you want. All they are just PNGs, transparent PNGs. And there's a bunch of different websites that you can use to port out those app icons. Also, I urge you to make cooler app icons. All this flat design shit is really boring, and I miss the old school days of, like, you know, the to-do app on your iPhone actually looked like a book where you actually wrote things. I miss those, like, high design days, so please bring those back. Dark mode, if you use light mode, you're a psycho. I like dark mode, but you can have native dark mode built in. This is actually really cool, the device access. I worked for a company before Garmin that we did a lot of device integration with Electron apps where we used Bluetooth and serial and USB ports, which are really fun to read off of sensors or accelerometers. You can get all that information from apps, which is really cool. In-app purchases, this only currently works on Mac because of the Mac App Store. But in-app purchases are available. Keyboard shortcuts, deep links, desktop launcher actions. This is a Linux thing. I'm not entirely sure what that does. Dock menu, specifically for Mac, so you can have those fancy dock bouncing icons. Native file drag and drop. This is really cool, especially if you're working with a lot of data files or images or things like that. You can just drag and drop those in to load them. Notification, native Windows, Linux, and Mac notification windows, progress bars, system trays. That actually brings me to a really cool point, is that these are not just, or Electron is not just for full windowed desktop apps. You can actually build system tray icon apps. You can build Mac bar apps if you want to. So they just drop down and you have, you know, just a couple different actions. They don't have to be some big web thing. It can be through menus and hotkeys if you want to. A great example of this is Magnet for the Mac. It's a Windows manager. It's just a system tray app, and it's all run on on keyboard hotkeys. So you just type a keyboard or a hotkey, and the windows move around to whatever position that hotkey is for. Really cool thing. Windows customization, obviously, and then menu customization. So you'll be able to fully control not only the top bar, where it says File, Edit, View, although you have full control over that, but you also have full control over your right-click menus as well. So if you have specific functions or actions that you want to do on right-click, you can have those as well. But wait, there's one more thing. Whoever was reading ahead, this is the surprise. Okay? It's not as cool as like a new iPhone, but I got to throw it in there. So there is a new project. It is called Tori. Has anybody ever heard of Tori? One? Okay. So Tori is a toolkit that helps developers make applications for the major desktop platforms using virtually any front-end framework in existence. It's built with Rust, and the CLI leverages Node.js. So this is a relatively new project. It's only been around, I want to say, like 2015, 2016, but it's really been gaining traction lately, and let me tell you why. So the only caveat to setting up Tori is that you have to have Rust installed, which does take some time. You do have to have all this Xcode developer dependencies installed. It does take a little bit of time, but it's not too bad. So these are the commands straight off their docs. And this is what they support. So obviously all the Linux stuff down at the bottom. These are a lot older versions of Linux. And we'll start back at the top. So this actually supports Windows 7 and up, as opposed to Windows 10 and up with Electron. Mac OS 10.15. I lost track of the numbers and the names for Mac OS. I can't keep them straight anymore. Like, just go back to the cats and call it good. Linux, obviously the bottom, but the two that are really interesting are the ones at the bottom where it says iOS and iPad OS, and then Android. So they're currently working on, they have alpha versions of these builds out, I believe, from last December. I haven't checked on them lately. But with Tori, the plan is that you have one singular repo that you port out to every platform that you need. You'll be able to port it to iOS, Android, web, desktop, all the different things. Like how many people use applications on multiple different systems? It's the same application, but it's on different, like a web interface or a native desktop app, things like that. Yeah, I'm the same way. I use different apps different ways, but I like the ability to access any of that data from any system that I'm currently working on. So if I'm on my phone, I know I can access it. If I'm on my desktop, I know I can access it. If I'm on a friend's app or a friend's computer, I know I can access it. So this is their goal. They're really trying to be the one singular source of truth when it comes to app development. So once we have Rust installed, we're able to install it, just the Tori app CLI, and it automatically adds the Tori script to your package JSON. And the only thing that we need to run is npm run Tori init. Notice how I did not say that we had to add extra files to the root of our application. All of that is already pre-installed with the CLI. There's nothing else that we have to install there, which makes the installation a lot easier. There's not a lot of boilerplate that we have to copy and paste, and oh, my linter got it wrong, or things aren't working properly because I fat-fingered a quote. Tori just takes care of that for us. So in order to run our application, npm run Tori build, and then it spits out all this stuff. The one thing that I do like about Tori is it automatically creates, if you're on Mac, it automatically builds for Macs, and it automatically creates a DMG file, so you can install it automatically. You just have an install file, and you can port that around to wherever you want. But the big thing about Tori is that file size. You can see where it's only down to 6.1 meg. Now this is literally the exact same application that I showed you on an Electron.js app. And you're probably wondering, why is it so small? Well, Tori, instead of packaging Chromium in every single instance, it uses the operating system's native web renderer in order to display the web content. So for Mac, it's going to be Safari. For Windows, it's going to be Edge, which is Chromium. Linux is probably something cool I've never heard of. But it doesn't have to, you don't have to build out Chromium and install it multiple times on your system in order to have an efficient app. So like I said, this is a very small app. Like it's literally the exact same app that I had previously, and I cut the file size down by what, 236 megs? 234 megs, sorry. So not bad, not bad at all. Let me kill this. We good? We're good. Okay. So let's talk about some of the Tori features. Very similar to Electron. It has a wide variety of features, but unfortunately they haven't been around as long as Electron. They don't have necessarily the community that Electron does, so there are some limitations. But for the most part, most of the interactions are all the same. Custom build APIs, interactions with Rust, the events system, icons, Windows menu, multiple windows, plugins, splash screen, system tray, Windows customization, all those things. Those are all customizable in Tori applications. And that URL down here is a curated list of just awesome plugins and things that you can do with Tori. So what's next? Ooh, sorry. Is there anybody that already builds desktop applications or works with Electron or Tori? Not you, Mike. Get out of here. Wait, are we recording that? Oh, great, great. Now it's recorded forever. Appreciate that. Sorry. No. Anybody actually build desktop apps? Yeah. What do you use right now? Yeah, you do use Electron? Awesome.
I came to audit your class for you, let you know what you explained right and wrong.
Perfect.
No pressure.
Oh, okay. Please rip me apart later. I'll be humble about it, I promise. So, a couple things that we need to worry about is if you're using Electron, really consider your performance optimizations. So we're talking about monitoring CPU usage and identifying performance bottlenecks. Excessive CPU usage can indicate inefficient code, execution computationally intensive tasks, or suboptimal resource utilization. So basically you coded it wrong and it's screwing up. So make sure that you do it right. So manage memory consumption. Keep an eye on the memory usage of your app. High memory consumption can lead to performance issues. Has anybody had Slack just like take over their machine and the fans kick on and it sounds like a goddamn rocket's about to take off? Yeah, that's a memory consumption issue with Electron. So they need to work on their stuff too. And also rendering performance. So applications that rely heavily on rendering web content should be monitored for rendering performance bottlenecks. Long rendering times, excessive layout recalculations, or inefficient use of animations and transitions can negatively impact your user experience. Mike in the back has a really great talk about building performant apps when it talks about animation protocols. This is definitely in that realm of making sure that you're optimizing the right things. So for testing and debugging, we utilize a couple different things. So we have access to testing frameworks, Spectron, which is an Electron specific testing framework. You do have access to Cypress, which is really cool because that's what I use. VTest, again, I use that. And Playwright. Does anybody use Playwright? Debbie O'Brien would be so mad right now because only one person uses Playwright. But Playwright is super cool. So you definitely have those testing frameworks that you can use. For debugging, especially in Electron, you have access to the Chrome DevTools, like I said. And then error handling and logging, you can use Sentry, which is a third-party service, or Log4j, you can use that too. So by incorporating these testing frameworks and utilizing the debugging tools and effective error handling, you can ensure the reliability and quality of your Electron.js apps. So security considerations. So secure external content. Apps should be cautious when loading external content, such as web pages or remote resources. So basically, don't use iframes in your apps. Just don't do it. It's stupid. Validate and sanitize user-generated input. Obviously, that's kind of a regular web dev technique. Do it on the front end, do it on the back end, make sure that all that data is sanitized. Secure communications. Obviously, you want to use HTTPS for whenever you can when interacting with APIs or transmitting any kind of sensitive data. And then secure native Node.js apps. Apps should be mindful when utilizing Node to access system resources, avoiding executing untrusted code or relying on user-controlled input without proper validation. Most of that probably comes from questionable NPM packages because you were just lazy and didn't want to write one function. You just used somebody else's code. So maybe don't do that. It also limits access to sensitive API information and implementation for authorization mechanisms to prevent unauthorized access to and potential abuse. So understanding these security risks and adopting these security best practices can really work on securing your communication, controlling access to system resources, mitigate security vulnerabilities, and enhance the overall security posture of Electron.js apps. Working at Garmin, I am very security-minded. They're a big company, and in early summer of 2020, when everybody was locked down, there was a ransomware attack, and our entire system was down for 3 days. Since then, we have not had any issues, but we are a very security conscious company, so a lot of this stuff is really important. So, in summary, Electron.js and Tori offer several compelling reasons to choose it for your desktop application development. Again, it's cross-platform compatibility. With Electron and Tori, you can build your desktop apps and run seamlessly on all the different operating systems. You don't have to relearn a bunch of stuff. You can use the web technology that you're familiar with, just HTML, CSS, JavaScript, use Vue. That's just my little plug. So you don't have to learn a bunch of new stuff. You don't have to learn a different format or a language. You can just utilize the stuff that you already have access to. It accesses native APIs and resources. So if you're trying to do something with the system the operating system, you definitely can. Electron, like I said, has a vibrant ecosystem and community. Their forums and their web portals are very, very important for learning. There are a lot of examples, a lot of projects that you can check out. Tori's is growing, and especially being a little bit more ambitious than Electron, in my opinion. They're growing at a faster rate, so there's going to be a lot more tutorials and plugins for Tori pretty soon. But the biggest thing for me is the rapid prototyping and the iteration. If you already have a web application, all you have to do is install Tori or Electron, and you can port it out as a desktop app like in 5 minutes. You know, if your boss says, hey, we need a desktop app of this, boom, you can do that really, really quickly. So it quickens the development cycle. They can build, test, and iterate their applications swiftly, reducing time to market and enabling efficient product development. Which for me, as a person that grew up in the marketing and advertising world, that's critical. If you don't hit your deadlines or you don't get first to market, you're going to be behind. So, in conclusion, overall, Electron and Tori offer powerful frameworks for building cross-platform desktop applications while providing access to native capabilities. It combines the best of both worlds, making it an excellent choice for developers looking to build feature-rich, efficient, and visually appealing desktop apps. So with that, this is a QR code, just goes to my links. If anybody's interested, please scan that. Otherwise, I do have my slides up here and links to the different GitHub repos that have these different apps that you can go and explore yourself. Does anybody have any questions, comments, concerns? How'd I do? Oh, why thank you. But yeah, so do we have time? Stupid watch. Yeah, we got a little bit of time. So I used to work at a company called Dimensional Innovations in Kansas City. If anybody's been to the Mercedes-Benz Stadium and seen any of the signage or digital activations that are there, that the company that I work for did that. They're an experiential. They are an experiential design firm. So a lot of colleges, museums, children's museums, anywhere where people can actually like physically touch things and explore things. That's kind of their bread and butter. And the apps that we built were not for the web. They lived on one computer that was in like a server closet somewhere on a local network, right? We had no outside internet access to access these things. So we would build Electron apps and basically treat them like full screen, touchscreen apps on touchscreen monitors that you could interact with. It was a really great solution, and it allowed us to spend more time on the design and more time on the functionality of the app, as opposed to trying to figure out, oh, well, how does it work on Mac? Or how does it work on Windows? It didn't matter how it worked on those different operating systems. It would work guaranteed on any system we wanted to. So if a customer came to us and said, hey, we want to have this app, but we don't want to spend a bunch of money on, like hardcore computing power in these server closets, can we just get away with like a Mac Mini and just plug it in there? It's like, yeah, we totally can do that. So we would just export it out from Macs. It was a really great solution. And though I haven't worked in Electron and Tori in a little while, I'm really passionate about bringing desktop apps back. I think a lot of people still use them. Not everything is built for the web, regardless of what everybody else here will say to you. Everybody uses desktop apps. And especially with Tori, them focusing a little bit more on the mobile side of things, we'll eventually be able to get to that space where we'll be able to port one thing to everything. So yeah, that's my spiel. My name's JD. Thank you guys for coming. Yeah, that's it.
Do you have anything that you recommend for syncing offline data?
As far as like an application that does it?
Yeah, like you need to do some data collection offline. You need some data from a server. You have to get it while you have an internet connection, and then go offline, and then access it, enter stuff, and then get back online and sync it again.
Right. So one of the things that we did is we used Amazon S3 to store all of our images and files and data and stuff. And what we would do is we would set a timer that every night at like 3 a.m, the entire system would reboot, right? It would shut everything down, bring everything back up. And what it would do is we wrote this so it would reach out to the S3 bucket and it would do a full sync of literally everything that's in there, right? And then there was a helper function that translated the like the S3 URL to a local URL, and then we would read that in the next day's application. Now, if we did have an application that needed to be updated, those functions could be updated manually, but they were usually on like a 24-hour cycle to sync. Honestly, museums don't update their applications very often, so it never really came up as a big issue.